Okay, in this video, we'll complete our study of multiple regression. We're going to talk about what's called qualitative independent variables. So in our last example predicting computer spending, we had, first of all, quantitative independent variables, which you could basically measure. For instance, GNP per person. That has a numerical value. You can measure that. Okay. But qualitative independent variables are things like the quarter of the year. Like the first quarter of the year might be January through March. It will be in our example. And that might affect auto sales, which we're going to try and predict. The second quarter of the year might be April through June. And the third quarter might be July through September. And the fourth quarter might be October through December. Or the qualitative variable might be, did we give a coupon this week? We're trying to predict sales of dog food. And the question is, how do you model qualitative variables? Well, the idea is you give yourself a 1 if the qualitative variable happens during that data point and it's 0 otherwise. So for instance, for the quarters of the year, well, let's look at our example. We have quarterly auto sales. This is in thousands, so these average about 3 million per quarter. Or 2.5 million, whatever. Pretty old data, 2.4 million per quarter. And so the first quarter, when this is a 1, it's the first quarter of the year, January through March, the second quarter of the year, April through June, etc. And we believe auto sales are seasonal. We'll see soon that the second quarter of the year, April through June, is the best for auto sales. Okay? But we can't just have one column that's a 1 for Q1, a 2 for Q2, a 3 for Q3, and a 4 for Q4, because that would imply the fourth quarter had 4 times the effect of the first quarter, which simply is not true, necessarily true. So what we do is we have a column for each of these qualitative variables. Q1 will be 1 if it's the first quarter of the year, 0 otherwise. Q2 will be 1 if it's the second quarter of the year, 0 otherwise. Q3 will be 1 if it's the third quarter of the year, 0 otherwise. Now you have to leave out one of the values for the category of that you're using, in this case seasonality. If you would put in the Q4 column, we'll see what the problem would be in a second. Okay, the computer will not be able to, Excel will not be able to run the regression. Okay, because there's something called multi-collinearity, which we can explain once we fill in these columns. But if you're using months of the year, you pick any month of the year to arbitrarily leave out, like December. Okay, and the way in this case you'll know it's Q4 is Q1, Q2, and Q3 are all 0. If you left out December with monthly data, you'd know it's December because the columns for each of the other months would be equal to 0 in December. Okay, well, in addition to the quarter of the year, economic variables may affect sales of cars. And so we're going to use GNP, unemployment rate, and interest rates. Now, the problem is we can't use the current quarter's GNP to predict sales during the current quarter because we don't know the GNP till the end of the quarter. And unless you can get time travel to work out, which some physicists think is possible, that's not going to help you. So we use last quarter's economic variables to predict next quarter's auto sales. And that's called lagging. So when I say lagged GNP, lagged unemployment rate, lagged interest rate, I'm using last quarter's values of those independent variables. Okay, so we're going to predict sales, which is going to be right here. And we're going to use these 6 columns to predict sales. Oops. So we've got to fill in this data, run the regression, and then interpret it. Okay. All right. So how do I put a 1 in the Q1 column? It's Q1. I use an if statement. Easiest way to do this, put a 1, 2, and 3 here. And I could say if the quarter we're in, and I've got a $sign the column to copy this across, equals 1 in this case. Okay, $, the row there. And I'll put a 1, otherwise, oops, sorry. Then I'll put a 1, otherwise a 0. Let's copy that down and see if every first quarter do we get a 1 there. Double click the left mouse. See, that's a first quarter, we get a 1. That's not a first quarter, we get a 0. And if I copy that across, I can get the Q2 and Q3 stuff. See, this is a Q2, I get a 1. It's not a Q3, I get a 0. Double click and copy it down. Let's check that it works. See, that's a Q3. How do I know it's a Q4? Q1, Q2, and Q3 are 0. See, if you put in a Q4 column, if we had a Q4 column, in each row, the Q1 column plus the Q2 column plus the Q3 column plus the Q4 column would always equal 1. And if you have an exact linear relationship like that between your independent variables, Excel cannot run the regression. It's like dividing by 0 or inverting a matrix that has no inverse, if you know what that means. Okay, now how do I get last quarter's GNP? Okay, well, last quarter's GNP is simply point to this cell. Last quarter's unemployment, just copy that across. Okay, double click the left mouse, and now I've got all the data I need to run the regression. And at this point, I think we know how to run a regression. Okay, so we go data, data analysis. Oops, sorry. We'll get the solver later. Data analysis, regression. And the Y range would be the sales. The X range will be the data right here. Have labels in the first row. Output range, why not? We'll put it over here. Residuals will show the actual minus predicted for every data point. Okay, now this should work out. Okay, so I got R squared. Let's look at what we've got here and interpret the output. Okay, so the equation we would use to predict sales, or quarterly auto sales, would come from the coefficient column. This is in thousands of cars per quarter. So predicted sales in thousands is 3155 plus 156.8 Q1 plus 380 Q2 plus 203 Q3 plus 0.174 lag GNP minus 94 lag unemployment minus 74 lag interest rate. Okay, now we want to check, are those independent variables significant? Look at the p-values. They're all less than 0.1 except for Q1. In other words, for example, there's only one chance in 1,000 that last quarter's GNP does not affect car sales. Okay? Now we have a 12% p-value for Q1, so we could drop that. But since Q2 and Q3 have low p-values, I'm going to consider these indicator or dummy variables, as they're called. They're often called qualitative independent variables, dummy independent variables, or indicator independent variables. Okay, and since the Q2 and Q3 are important, I'll consider a package deal and leave in Q1. And so in this video, the R squared is 78%. In other words, our model explains 78% of the variation in auto sales. the standard error of the regression is 191,000. So we'd expect 95% of our forecasts to be accurate within 382,000. Okay, now is that good or not? Well, remember the average value of auto sales is about 2.4, 2.5 million. So if 95% of the time I can get that right within 15%, you have to decide if that's good enough. Are there any outliers? Looking at the residuals column, we would find that there's no outliers. None of those numbers exceed 382,000 in absolute value. That's not good, right, or wrong. It's just a fact. Now let's interpret the coefficients. Okay, so what does that 0.174 mean? And all these interpretations are ceteris paribus after adjusting for all the other independent variables. Okay, so 1 billion in GNP is 0.174 increases sales by 0.174 cars, but that's in thousands, by 174 cars. Okay, that's last quarter's GDP, of course. 1% increase in the unemployment rate should reduce sales. By 94,000 cars. Makes sense. And a higher interest rate should reduce car sales because it costs more in effect to buy the car. So a 1% increase in interest rates last quarter again, and all these are after adjusting for everything else, decreases car sales 74,000. Okay, now what about the indicator variables, the Q1, Q2, and Q3? They're interpreted relative to Q4, which is left out. For instance, if you have a Q1 equal 1, if it's a first quarter, Q1 is 1, Q2 and Q3 are 0, you get the plus 157. So basically, relative to Q4, Q1 is 157,000 more cars than Q4, the one left out. Look at Q2. If it's the second quarter, Q1 would be 0, Q3 would be 0, Q2 would be 1. Q2 is basically 380,000 more cars in the forecast than Q4. And Q3, if it's the third quarter, Q1 and Q2 are 0 and Q3 is 1, is basically 203,000 more cars than Q4. So Q4 is the worst quarter and Q2 is the best quarter. And that's probably because summer's coming up and we get tax refunds and stuff like that. I'm not really sure of that. Okay, now to see if you test your understanding, suppose instead of leaving out Q4, you left out Q2. Then the coefficients of all the other indicator variables would be negative because every quarter is worse than Q2. So I think this video and the preceding two videos should give you a good introduction to multiple linear regression, how to use that in Excel. It's probably one of the most useful tools in forecasting and trying to understand sort of what makes the world tick, trying to predict one variable, the dependent variable, from many independent variables. I should mention Excel has a limitation of 15 independent variables in the data analysis add-in, which is pretty low. Okay, well that completes this video.
Okay, so thanks for watching, and there's a free course, a free 21-day course from Dr. Winston, and all of these videos are coming from one of 3 books. So first, this one, which you can see here at the top of the screen, Microsoft's book, which has 355 reviews, and then it's, let's see, 4.6 stars. It's coming from this book as well, his marketing analytics book, which is down here, and you can sort of see 4.5, or his newest book, his analytics stories book, which is here. And with that one, you can see it's 4 point something, or maybe even 5. I don't think it's 5. Yeah, 4.8. And so, yeah, anyways, in the description, there's a free 21-day course from Dr. Winston, or you can go to excelwithwayne.com/free, and it'll be there. But again, thanks for watching, and if you have any questions, just please let us know. Thanks.